The possibility exists that temporary lighting may be required to be three-wire in the future for safety reasons. Several factors could contribute to the shift. Firstly, increased safety is a primary concern. A three-wire system, also known as a grounded system, provides an additional path for fault current to flow. This reduces the risk of electrical shock and fires. In temporary lighting applications, cables are often exposed and may be subject to damage. A grounded system offers an extra layer of protection. Secondly, compliance with codes is essential. Electrical codes and standards are constantly evolving to improve safety and efficiency. Future revisions of electrical codes could require temporary lighting to be three-wire for certain applications or environments. Thirdly, advancements in technology play a role. The development of new technologies, such as LED lighting fixtures and portable generators, could make it more feasible to implement three-wire temporary lighting systems. LED fixtures typically have lower power consumption and reduced heat generation. This reduces the load on the electrical system and makes it easier to provide adequate grounding. Also, industry best practices are evolving. As the construction industry becomes more focused on safety and risk management, industry best practices may shift towards requiring three-wire temporary lighting as a way to mitigate potential hazards. Currently, temporary lighting is primarily manufactured with two-wire systems, but a move towards three-wire systems in the future is not impossible. The decision will depend on factors such as safety considerations, code requirements, technological advancements, and industry trends. Grounding is a critical aspect of electrical safety. It provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This prevents electrical shock hazards and reduces the risk of fires. A three-wire system includes a ground wire in addition to the hot and neutral wires. This ground wire is connected to the earth at the service entrance and provides a direct path for fault current. In contrast, a two-wire system typically only includes hot and neutral wires, without a dedicated ground wire. In the event of a fault, the current may flow through unintended paths, such as a person touching a metal enclosure, creating an electrical shock hazard. Temporary lighting applications often involve temporary wiring and connections which can be more susceptible to damage or degradation. This increases the risk of electrical faults and the need for effective grounding. The National Electrical Code, also known as NEC, Article 590 covers temporary installations. It outlines the requirements for temporary electrical power and lighting installations used during construction, maintenance, repair, or demolition of buildings or structures. It emphasizes safety measures to minimize hazards associated with temporary wiring and equipment. The NEC addresses several critical aspects of temporary lighting, including grounding, overcurrent protection, and the use of ground fault circuit interrupters, known as GFCIs. It mandates that temporary lighting systems must be properly grounded to protect against electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are required to protect against overloads and short circuits. GFCIs are often required in damp or wet locations to provide additional protection against ground faults. Different types of temporary lighting are used in construction and other applications. These include string lights, floodlights, and work lights. String lights are commonly used for general illumination and are often strung along walkways or scaffolding. Floodlights provide high-intensity lighting for larger areas, such as construction sites or outdoor events. Work lights are portable and adjustable, providing focused lighting for specific tasks. The selection of temporary lighting depends on the specific requirements of the application, including the area to be illuminated, the level of illumination required, and the environmental conditions. When selecting temporary lighting, it is essential to consider the wattage and voltage requirements of the fixtures. The wattage determines the amount of light produced, while the voltage must match the available power supply. It is also important to choose fixtures that are suitable for the environment in which they will be used. For example, fixtures used in wet locations must be rated for wet locations. The use of LED lighting in temporary applications offers several advantages. LED fixtures are more energy efficient than traditional incandescent or fluorescent fixtures, reducing energy consumption and costs. They also have a longer lifespan, reducing the need for frequent replacement. LED fixtures generate less heat, reducing the risk of burns and fires. Furthermore, they are more durable and resistant to vibration and impact, making them well suited for construction sites and other demanding environments. Portable generators are often used to power temporary lighting in areas where utility power is not available. When using a portable generator, it is essential to ensure that it is properly grounded. This can be achieved by connecting the generator's grounding terminal to a grounding electrode, such as a ground rod. It is also important to use ground fault circuit interrupters GFCIs to protect against electrical shock. GFCIs detect ground faults and quickly de-energize the circuit, preventing electrical shock. Electrical codes require the use of GFCIs in many temporary lighting applications, particularly in damp or wet locations. Industry best practices for temporary lighting emphasize safety and risk management. These practices include regular inspection of temporary wiring and equipment, proper grounding, the use of GFCIs, and the provision of adequate lighting levels. It is also important to train workers on the safe use of temporary lighting and to ensure that they are aware of the potential hazards. The increasing focus on safety in the construction industry is driving a trend towards more stringent requirements for temporary lighting. This includes the potential requirement for three-wire systems and the increased use of GFCIs. The goal is to minimize the risk of electrical shock and fires and to create a safer working environment. The decision to require three-wire temporary lighting will ultimately depend on a variety of factors, including safety considerations, code requirements, technological advancements, and industry trends. While two-wire systems are currently the norm, the potential benefits of three-wire systems in terms of increased safety are significant. As technology advances and costs decrease, it is likely that three-wire temporary lighting will become more prevalent in the future. Changes to the NEC are made every 3 years based on proposals from industry experts and stakeholders. These proposals are reviewed and debated by committees, and the final decisions are made based on the best available evidence and the consensus of the committee members. The process is designed to ensure that the NEC remains up to date and reflects the latest safety standards and technological advancements. In addition to the NEC, other organizations, such as the Occupational Safety and Health Administration, known as OSHA, also play a role in regulating temporary lighting. OSHA sets standards for workplace safety and enforces those standards through inspections and fines. OSHA's regulations for temporary lighting are generally aligned with the NEC, but OSHA may also have additional requirements or interpretations. It is important for employers to be aware of both the NEC and OSHA requirements for temporary lighting and to ensure that their temporary lighting systems comply with both sets of regulations. The cost of implementing three-wire temporary lighting systems is a factor that will be considered when making decisions about future requirements. Three-wire systems typically require more materials and labor to install than two-wire systems, which can increase the initial cost. However, the long-term benefits of increased safety and reduced risk of electrical accidents may outweigh the initial cost. Furthermore, as technology advances and production volumes increase, the cost of three-wire components and systems may decrease, making them more cost-competitive with two-wire systems. The availability of skilled electricians is also a factor that will be considered. Three-wire systems require more expertise to install and maintain than two-wire systems. It is important to ensure that there are enough skilled electricians available to meet the demand for three-wire installations. This may require additional training and certification programs to ensure that electricians have the necessary knowledge and skills. The impact on productivity is another factor that will be considered. Implementing three-wire temporary lighting systems may require changes to work practices and procedures, which could affect productivity. However, the long-term benefits of increased safety and reduced risk of accidents may outweigh any short-term impact on productivity. Furthermore, by implementing efficient work practices and using appropriate equipment, it may be possible to minimize any negative impact on productivity. The environmental impact of temporary lighting is also a consideration. Traditional incandescent and fluorescent fixtures are less energy efficient than LED fixtures and may contain hazardous materials such as mercury. By using LED fixtures, it is possible to reduce energy consumption, greenhouse gas emissions, and the risk of environmental contamination. The disposal of temporary lighting equipment is also a concern. It is important to dispose of old fixtures and wiring properly to prevent environmental pollution. Many jurisdictions have regulations for the disposal of electronic waste, and it is important to comply with these regulations. The use of renewable energy sources, such as solar power, to power temporary lighting is also a growing trend. Solar-powered temporary lighting systems can reduce reliance on fossil fuels and low carbon emissions. These systems are particularly well suited for remote locations where access to utility power is limited. The maintenance of temporary lighting systems is critical to ensuring their safety and reliability. Regular inspections should be conducted to identify any damaged or worn components. Damaged wiring, loose connections, and broken fixtures should be repaired or replaced promptly. It is also important to keep temporary lighting systems clean and free of debris to prevent overheating and fire hazards. The storage of temporary lighting equipment is also important. Equipment should be stored in a dry, secure location to protect it from damage and theft. Wiring and cables should be coiled properly to prevent kinks and damage. It is also important to label all temporary lighting equipment clearly to identify its voltage and wattage requirements. The training of workers on the safe use of temporary lighting is essential. Workers should be trained in the proper procedures for installing, using, and maintaining temporary lighting systems. They should also be trained on the potential hazards associated with temporary lighting, such as electrical shock and fire. Training should be conducted by qualified instructors and should be documented to verify that workers have received the necessary training. The documentation of temporary lighting installations is also important. A record should be kept of all temporary lighting installations, including the location of the installation, the date of the installation, the type of equipment used, and the results of any inspections. This documentation can be used to track the performance of temporary lighting systems and to identify any potential problems. The communication of safety information is also important. Workers should be informed of the potential hazards associated with temporary lighting and the steps that they can take to protect themselves. Safety information should be communicated through signs, posters, and training materials. It is also important to encourage workers to report any safety concerns that they may have. The continuous improvement of temporary lighting practices is essential. By regularly reviewing temporary lighting practices and identifying areas for improvement, it is possible to reduce the risk of accidents and injuries. This can be achieved through the use of safety audits, incident investigations, and worker feedback. The goal is to create a culture of safety in which all workers are committed to preventing accidents and injuries. The adoption of three-wire temporary lighting systems is a complex issue with many factors to consider. While there are potential benefits in terms of increased safety, there are also challenges to overcome, such as the cost of implementation, the availability of skilled electricians, and the impact on productivity. However, by carefully considering these factors and working collaboratively, it is possible to develop solutions that will improve the safety of temporary lighting systems and protect workers from electrical hazards. The trend towards increased safety in the construction industry is likely to continue, and it is possible that three-wire temporary lighting will become more prevalent in the future. By staying informed about the latest developments in temporary lighting technology and regulations, it is possible to prepare for these changes and to ensure that temporary lighting systems are safe, efficient, and compliant with all applicable requirements. The future of temporary lighting is likely to be shaped by a number of factors, including technological advancement, regulatory changes, and industry best practices. By embracing innovation and prioritizing safety, it is possible to create a safer and more productive working environment for all.